Hey everybody, as you know I'm not here in class today, so I put together this video so that you wouldn't miss me. Plan for today, I had to have episode 5 up here, but our plan for today is you're going to watch this video and you're going to do it at your own pace so you can watch it on your own computer, and the link has been provided for you. Then you're going to do a worksheet that's handed out to you by the sub, and if you complete the worksheet before the end of class time, you can stay in class and work on other things and have free time until the end of the period. We went over this, just a quick review, things about electrons. Electrons want to be in the lowest possible energy state they can possibly be in. They're attracted to the nucleus because the nucleus is positively charged and the electrons are negatively charged, so they're attracted to each other. And they repel other electrons. So imagine that they want to be as close to the nucleus as possible, but as far away from the other electrons as possible. So that creates a contradiction that's going to really influence the way that they arrange in the atom. There are a few rules that electrons follow. The Aufbau principle is our rule already mentioned, where electrons occupy lowest energy orbitals first. Hund's rule is that one electron with parallel spin is going to go into each orbital of a sublevel before they begin to double up. Remember, the electrons don't want to be close to each other if they can avoid it, so they're going to occupy one orbital of the sublevel before they begin to double up. So in a p sublevel where there are 3 orbitals, you'll have one electron in each orbital with parallel spin, so imagine again all up arrows, before they begin to double up in those orbitals, because those orbitals are of equal energy, but they're better distributed, one in each, before they double up. That's Hund's rule. And then the Pauli exclusion principle, which explains that you can have no more than 2 electrons in any one orbital. So once we have 2 electrons in an orbital, that fills that orbital. The electrons have to find someplace else to go. Okay, we reviewed our quantum mechanics. We have our 4 quantum numbers where we have a main energy level 1, 2, 3, 4. We have sublevels S, P, D, F. We have orbitals, which we describe by using boxes, and we're going to learn a different way to do that. And then we have arrows where we indicate the electron spin, up or down. You're familiar with this. This represents the order from lowest energy state to highest energy state that the electrons will occupy orbitals. So we start with the first main energy level, S sublevel, then go to the second main energy level, S sublevel, then we go to the second main energy level, P sublevel, and so on. This diagram is in your textbook, chapter 5. I believe it's section 5.4, but it's somewhere in there, 5.3 or 5.4. So you can find it in your textbook if you want to refer to it. But again, this is going to tell us what order the electrons will occupy from lowest energy state to highest energy state. So box diagrams, we know that's when we use the boxes to put the arrows in to show the presence of electrons. What we want to do now is make that transition. But the box diagrams you're familiar with, we use a box to represent the orbital. That first box would be the first main energy level, S sublevel, 1 orbital. Then we move on to the second main energy level, S sublevel, where there's 1 orbital. Then we move on to the second main energy level, P sublevel, and we have 3 orbitals, so 3 boxes. After that, we go to the third main energy level, S sublevel. This is lowest energy to increasingly higher energy. That's the order that electrons will occupy the orbitals. So 1s, 2s, 2p, 3s is our order. After the 3s, we go to the third main energy level and establish a p sublevel that has 3 orbitals. So remember, 1 orbital for the s sublevel, 3 orbitals for a p sublevel, 5 orbitals for a d sublevel, and 7 orbitals for an F sublevel. We haven't gotten to the D's and the F's yet. So here is the box diagram set up. Then, as you know, we've done this in class, you're going to occupy these boxes one electron in each orbital of a sublevel before you double them up. So if I have 2, 4, 5, 6, 7 electrons, I'm going to have one electron in each of the second main energy level p sublevel orbitals before I begin to double them up. 2, 4, 5, 6, 7 electrons is going to be nitrogen. So this would be the electron box diagram for nitrogen. What I'm going to show you now is how we translate or transfer this into an electron configuration, which is just another way of representing the same thing. So instead of using boxes, as we do in a box diagram, with arrows, we take the label here, 1s, first main energy level, s sublevel, and then we use a superscript, super being above, to represent the number of electrons. 2. So the first main energy level, s sublevel, has 2 electrons. Notice that the 2 is a superscript up above. The second main energy level, no space between them, s sublevel, has 2 electrons. So I use a superscript again to show the number of electrons in the s sublevel of the second main energy level. Then I go on to the second main energy level, p sublevel, where there are 1, 2, 3 electrons. So my superscript is 3. So this is the electron configuration for nitrogen. Follow along. Instead of using a box with arrows, I take the name of that box, which is the first main energy level, S sublevel, first main energy level, S sublevel, and then I use a superscript to represent the number of arrows, the number of electrons in that S sublevel. Shorter, easier to do, a little less informative because it doesn't really show me where there are gaps. It just tells me how many electrons are in the sublevel. Is how do we use the periodic table so that we don't have to keep looking at that diagram that goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, so that we don't have to memorize that or keep looking at that diagram. We can use the periodic table. So to use the periodic table, you have to understand the layout of the periodic table. This is the S block for the S sublevel of the quantum numbers. This section here is the D block. And what that means is when you're working through this part of the periodic table, the electrons are being placed into the D sublevel of a certain main energy level. When you're here, say for sodium and magnesium, you're in the S block, so you're putting electrons into the S sublevel of a certain main energy level. Over here, we have what we refer to as the P block. When we're going through here, we're putting electrons into the P sublevel of a certain main energy level. So the blocks on the periodic table, they represent the sublevels. We can use the periodic table to identify what sublevels are being occupied by electrons. So a quick review, this is the S block here. Notice this gap right here, that's where helium belongs. So helium would actually fit into the S block. It's got 2 electrons. The first one's in the first main energy level, S sublevel, and the second one is in the first main energy level, S sublevel. And that's all the electrons that it has. Then notice that after helium, we come back here to lithium. We're now in the second period on the periodic table. This represents the second main energy level. So second main energy level, S sublevel, we can put 1, 2 electrons. Then we got to go to a new sublevel, so we go over here to the P block. The first main energy level that has a P sublevel is the second. The first main energy level doesn't have a P sublevel, it only has an S sublevel. So that's all done after hydrogen and helium. So we go lithium, beryllium for the second main energy level, S sublevel. Then we jump across this gap to get to the second main energy level, P. Remember that there are 3 orbitals in a P sublevel, 2 electrons max in each orbital, so 6 electrons total in the P sublevel. 1, 2, 3, 4, 5, 6. We get to neon, the noble gas. Then we have to go all the way back down to the third period, which is where we're starting the third main energy level, where we go with an S. Sodium has 1 in the 3s, magnesium has 2 in the 3s. Then we jump across to the third main energy level's P sublevel. Remember, this is the P block, where we can put 1, 2, 3, 4, 5, 6 electrons, 2 in each of the 3 orbitals. We get to argon. Make note that we're at the noble gas when we get to the end. We go all the way back over here, down to the fourth period, which is the fourth main energy level, where we start with the S. 4s, 1, 4s with 2 electrons. Then notice we enter the D block. The first main energy level that has a D sublevel is the third. The first main energy level has 1 sublevel. The second main energy level has 2 sublevels. The third main energy level has 3 sublevels. An S, a P, and a D. So the first D sublevel is in the third main energy level. So we've started the fourth main energy level here, where we have the S. Now we're going back to the third main energy level into the D. So this would be 1 in the D, 2 in the 3D, 3 in the 3D, and so on. Remember, there are 5 orbitals in a D sublevel, 2 electrons in each orbital, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in the 5 orbitals of the D sublevel. So when we get to zinc, we filled that D sublevel. Now we go into the P block. This was the 2P. This is the 3P, so this has to be the 4P. So going back over to here, for potassium, 4s1. For calcium, 2 electrons in the 4s. For scandium, we start the third main energy level, D sublevel, where we put 10 electrons to get to zinc. Then we go into the second, third, fourth main energy levels, P sublevel, where we put 6. Get to krypton, noble gas. Bing! Go back to the beginning. Rubidium, 1, 2, 3, 4, 5s. 4D. This is the 3D, this is the 4D, this is the 5D, this is the 6D. The one thing we haven't noticed yet is down here we have the F block. Remember, there's an F sublevel that has 7 orbitals. 2 electrons in each orbital allows us to have 14 electrons in that F sublevel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons in the F sublevel. Lanthanum and actinium actually fall in here where they're going to be in the D block. So those are kind of funky exceptions we don't have to worry about right now. So putting electrons into the S sublevel when we're here, putting the electrons into the D sublevel when we're here, putting electrons into the P sublevel here. Remember that helium belongs in the S block. And then we have the F sublevel, electrons being occupying when we're down here. Main energy level, first, second, third, fourth, fifth, sixth, seventh for the S's, 3, 4, 5, sixth main energy level for the D's. There is no 1P, so we start with the 2P, 3P, 4P, 6P, 7P. 2P, 3P, 4P, 5P, 6P, 7P. We always finish a main energy level when we get to the noble gases and start a new one when we move to the next alkali metal. So that's a lot. We're definitely going to talk about this in class. So if you're not picking it up too well right now, don't worry about it. We will spend some time on it. Today, the primary focus is on the worksheet. The worksheet's going to take you through box diagrams and questions about the box diagrams and doing electron configurations. If you have any questions, Dr. Moon is available for both periods, Block 2 and Block 6. So if you're really in a crisis, we can track her down and she can come in and maybe give you a little help during class. Otherwise, do the best you can with the worksheet, and I will see you all on Tuesday. Have a great weekend.